When we think of Saturn, our eyes are drawn to the rings, vast, icy, and iconic. But beyond those glittering bands lies a force you can't see: Saturn's magnetosphere, one of the largest and most powerful magnetic fields in the solar system. This invisible shield extends more than 1,000,000 kilometers into space, forming a protective bubble that envelopes the planet and its dozens of moons. It's driven by the motion of metallic hydrogen deep inside Saturn, spinning like a massive electrical generator and creating a magnetic force over 500 times stronger than Earth's. But what really stuns scientists is how perfectly aligned it is. Saturn's magnetic field is almost exactly centered on its rotation axis, a feature that defies what we know about planetary dynamos. Earth's field wobbles, Jupiter's is tilted. Saturn, it spins with magnetic symmetry so precise, it's almost unnatural. Inside this vast region, high-energy particles spiral along magnetic field lines, forming intense radiation belts. But Saturn's magnetosphere isn't just shaped by the Sun, it's also fed by its own moons. One of the biggest contributors is Enceladus, a tiny icy moon that spews out plumes of water vapor and ice. Those particles get swept up by Saturn's magnetic field, creating a torus, a giant donut-shaped ring of plasma, that surrounds the planet. This plasma fuels dynamic interactions, producing giant, glowing auroras at the poles. These auroras can be seen in ultraviolet and infrared, lighting up Saturn's atmosphere like a cosmic neon show. Cassini gave us our first real glimpse inside this magnetosphere, flying through the plasma belts, measuring electric fields, and tracing the way energy moves through space. What it found was a magnetic environment alive with motion, stretching, snapping, and reconfiguring itself in response to both the Sun and Saturn's own inner power. It's not just a shield, it's a living system, one that protects, evolves, and connects the planet to the solar wind beyond. True or false, Saturn's magnetosphere is generated by the movement of molten rock inside the planet. False, Saturn's magnetic field is generated by the motion of metallic hydrogen deep within the planet, not molten rock. What drives Saturn's powerful magnetosphere? Metallic hydrogen movement. Fill in the blank. Saturn's magnetosphere is the blank magnetic field among the gas giants after Jupiter. Second largest. Fill in the blank. The internal motion of blank hydrogen powers Saturn's magnetic field. Metallic. Which moon creates a torus of plasma inside Saturn's magnetosphere? Enceladus. If a particle travels 1,800 kilometers across Saturn's plasma torus at a speed of 450 meters per second, how long does it take to complete the journey? We start by converting 1,800 kilometers into meters, which gives us 1,800,000 meters. Then divide by the speed, 450 meters per second, and we get 4,000 seconds. That equals 66.67 minutes for the particle to make its full trip through the plasma torus. True or false? Saturn's magnetic field is unusually aligned with its rotational axis. True. Fill in the blank. Saturn's magnetic field is almost perfectly aligned with its blank axis. Rotational axis. What shape do the charged particles form around Saturn due to its magnetosphere? Plasma torus. Fill in the blank. Saturn's blank lights up with auroras fueled by magnetic activity. Atmosphere. True or false? The Moon Enceladus contributes material to Saturn's magnetosphere. True. A charged particle zips through Saturn's magnetic belt at 600 meters per second for 5 minutes. How far does it travel? Start by converting 5 minutes into seconds. That's 300 seconds. Then multiply the speed, 600 meters per second, by 300 seconds to get 180,000 meters. Since there are 1,000 meters in a kilometer, we divide by 1,000 to convert to 180 kilometers. That's how far the particle travels while racing through Saturn's magnetic belt. Which mission gave us detailed data on Saturn's magnetosphere? Cassini. Fill in the blank. Cassini flew through Saturn's blank to collect data on its magnetic environment. Magnetosphere. A probe crosses 900,000 meters of Saturn's inner magnetosphere in 15 minutes. What is its average speed? First, convert 15 minutes to seconds. That gives us 900 seconds. Then divide the total distance, 900,000 meters, by the time, 900 seconds. The result is 1,000 meters per second. That's the average speed of the probe as it moves through the inner regions of Saturn's powerful magnetosphere. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, brainy friends.